In this video, we are going to talk about ionic compounds that contain polyatomic ions. So, reminder, polyatomic ions, they can be confusing because when you first look at them, you'd say, ooh, that's a nonmetal and another nonmetal, which would, if you said, I have a nonmetal and nonmetal, I know that it's going to have covalent bonds. Covalent bonds. And you're right, it absolutely does have covalent bonds. If I were to draw CO3 minus 2, it has covalent bonds. But because oxygen doesn't have its normal number of bonding, usually it has 2 bonds. In this case, it has less than that, and it keeps a lone pair. It has a minus charge. So we have to recognize that when I first look at this in a formula, I have to recognize that carbonate, CO3 minus 2, is going to be in ionic bonds. It can have ionic bonds because it has a minus charge. So you can imagine if I had a sodium plus here and another sodium plus here, there would be an attraction between those two minuses. But if I condense this down, this structure down, I could give you the chemical formula and say Na2CO3, and that might feel very confusing to you as a student because you'd look and you'd say, okay, I have a metal, yes, but what the heck is this? This is not on the periodic table. It's not on the periodic table because it's a polyatomic ion that has 2 nonmetals combined together that give you a minus charge. Okay, so you are expected to know these polyatomic ions. I will say I hate memorizing, but these are actually really useful. So I hope that you have taken the time to memorize them. If not, there is always today and tomorrow and the next day. So let's get started. We know these polyatomic ions can form ionic bonds. And this is just reminding you where my nonmetals are. I feel like we've done this a million times, but just one more time in case people don't know. Don't forget hydrogen. Hydrogen's also a nonmetal. Okay, so what does this chemical formula mean? Well, the subscript 2 tells me I have 2 sodiums. And if you were looking at the periodic table, sodium's over here, so you know it has a plus charge. And then you have carbonate. And you know it has a minus 2 charge because that's the way carbonate comes, and you've memorized that minus 2 charge on carbonate. So that 2 sodium, I have 2 sodiums, and I have to remember that this carbonate is a unit. I really do actually think of it as like a unit. I'm not going to split this guy up. Okay, so if you were looking at the next formula, you'd say Na. I can definitely look up Na on the periodic table, and it has a plus charge. And then you might look at oxygen and think, ooh, oxygen has a minus 2 charge if you weren't being careful. But if you recognize that OH, so that OH right there, that OH is this OH right here. It's a polyatomic ion that comes as a unit with an OH and a minus charge. So I have 1 sodium for every 1 hydroxide. Okay, let's do sodium sulfate, Na2SO4. Again, we know sodium is a plus. Oops, again, we know sodium is a plus. And the subscript tells me that there are 2. So the subscript tells me there are 2. And I have this whole unit didn't tell me that I have 1, but I know I only have 1 because it didn't specify more. In addition, I have 2 pluses for the sodium, which counterbalance that minus 2 on my sulfate. Okay, so I have 2 sodiums for every 1 sulfate. The plus charges, I have 2 of these pluses. They counterbalance that minus 2. All of that information came from the formula. But even if it didn't come from the formula, so let's say I gave you a transition metal. If I gave you a transition metal, you're like, oh no, transition metals. They don't tell me what the charge is. Well, I know what the charge on this one is because I know what the charge on this one is. Sulfate comes as a -2. I know it comes as a -2. It's a unit, it has a -2. So that copper would have a +2. Want to show you another cheat because I was not good at memorizing things. So if you gave me on an exam sodium sulfate like this, I could actually figure out the charge on sulfate without having to have memorized it. Of course, I want you to memorize them, but I'd say, ooh, I have 2 sodiums with a plus charge, and I have SO4. I recognize it's polyatomic, but I don't know its charge. Well, +1, +1. I know that's a -2. So desperate times, if you don't get around to memorizing or you just have a really tough time, you can hope that you can use some process of elimination to figure things out. Okay, let's do ammonium carbonate. So NH4, that's ammonium, ammonium, ammonium. And this is the first time ammonium, the NH4, that you've seen something that's not a metal in the front. It's not a metal in the front. What the heck is this NH4? Well, it's a polyatomic ion. It's our only polyatomic ion that has a plus charge. My ammonium has a plus charge. So it's written first. We always put the thing with the plus charge first. And I know it has a +1. So ammonium has a plus charge. And notice when we have a polyatomic ion, we have this polyatomic ion. When we have more of them than one, we have to use parentheses. So we put parentheses here to say, hey, this whole unit, the NH4, I'm going to have 2 of them. I have 2 NH4 pluses. I have 2 NH4 pluses. And it doesn't matter if you put the plus on the right side or if you put the plus on the left side, they're both the same. So I have NH4 plus and carbonate. You memorize that carbonate, CO3, has a -2 charge. It has a -2 charge. So what else do I want to say about that? I have 2 of these, so 2 ammonias for every 1 carbonate. Notice I just wanted to point out nomenclature thing because a lot of people missed that on the exam. Carbonate, O3, O3, O4. These are all sulfate, phosphate, nitrate, carbonate. The first 4 with multiple oxygens end in 8. So that should help you. Okay, next one. Actually, I'm asking you to do the next 3 on your own. So go ahead and do the next 3 on your own. And so pause it, do them, and we'll continue on with the next slide. Okay, so the other thing I need you to be able to do is if I give you the formula, you can give me the formula for it. So calcium, you look on the periodic table. It's right here. You know it has a +2 charge. So calcium has a +2 charge. That's the very first thing I'm doing. If I have to go from the chemical formula to the name, 1, assign charges. 2, how many do I need to have of each of them? How many do I need for each group? I don't know, because we have polyatomic ions in there, each group to make overall the overall molecule neutral. Molecular compound, doesn't matter how you say it, neutral. Okay, so I have a calcium +2, and I have a carbonate -2, -2 and a +2, they're going to equal 0. So calcium carbonate's not too hard. It's going to be Ca, PO3. Let's do calcium hydroxide. Calcium again. Calcium's going to be a +2. Hydroxide is a -1. I need these two charges to balance each other out. I have +2 on this side, so I need another one here, a -OH. I need 2 of these. That'll give me -2. This one's +2, so I'm good. Now, how do I write this as a chemical formula? I have calcium first. I always put the thing with the plus charge first. And now I need to do something weird. We haven't done this before. I need to express that I have 2 of these. So I need to express that I have 2. But if I just put a 2 in front, that's not going to make any sense. And actually I need it as a subscript, right? So if I put a subscript here, that would be OH2, which is not what it is. It's OH, the whole group, 2. So I need to use parentheses to make it a 2, to make that OH a 2. Hopefully that makes sense, and we'll get a couple more examples. But when I have a polyatomic ion and I have multiple of them, I need to put this parentheses down because otherwise the subscript will say something totally different from what we mean. Okay, let's do the next one. So let's do sodium phosphate. Sodium, you look on the periodic table, it has a +1 charge. And you have phosphate. It has a -3 charge. So I need 3 sodiums to give me a +3 total charge here to cancel that -3. Okay, so I want to express this in the chemical formula. The chemical formula for this would be Na, I have 3 of them, and then PO4. I don't need to put parentheses around it because I know that this is a unit. This whole thing, the PO4, comes as a unit. Okay, let's do the next one. Sodium carbonate. Always assigning the charges first. I have sodium with a plus, carbonate that comes as a unit with a -2, and I have 2 sodiums. To cancel out that -2, I need 2 of these. So I'm going to use a subscript behind the 2 to show that I have 2 of the sodiums. And then carbonate's a unit. I know it's a unit. It comes together. And because I only have 1, I don't need to use parentheses. Okay, let's do one more. I'm going to do, because I'm feeling frisky and nice, I guess not frisky, just nice. Let's do this hard one, this ammonium sulfate. So ammonium is a polyatomic ion. You recognize it from over here, and it has a plus charge. So this is a whole unit. I just kind of want to recognize this whole thing comes together. It's a unit. I'm not breaking it apart. Sulfate, also a unit. Sulfate -2 is a unit 2. Okay, now how many ammoniums do I need to cancel that -2? I have a -2 here, and I have a +1 here, so I need another one. Okay, now my charge is +2 on this side and -2 on that side. We're good. Now I need to write this. So I have NH4, and I have 2 of them. I cannot put the 2 out in front because if I put the 2 out in front, it's going to be for the whole darn thing, right? So I need to make sure that I put parentheses around it to express that I have 2 of that yellow unit, that ammonium. This is my unit. I have 2 of them. That's what that parentheses is for. Okay. Hopefully this is not too tricky. Enjoy the practice, and I will see you in the next video.